Okay, now we're live.
Okay. Hi, everyone. So welcome to the data-intensive biology training on Git today. So this is actually part of a training series based out of UC Davis, run by Titus Brown. And Jessica is a really helpful person, helping managing all the logistics going on. And part of data-intensive biology, there's a whole series of trainings. Today we're talking about Git. There's a whole bunch of trainings in the future, and there's a bunch of past trainings that are all recorded for you to look at as well. So, Git. The reason why a lot of people here are here today is to learn Git, and one of the most useful use cases for Git, especially from a researcher's perspective, is this final doc problem. Every time you write a document or a piece of code, we want a better way to version control our work. And we've all had this problem where we think something's finished, we put the word final on it, but we know that it's never really the last one. And this is fine if everyone's done this. I do this sometimes. It's faster than just going through the whole Git process of getting something done. But if you plan to share your work, or you plan to look back at your work, or if you care about yourself in about 2 weeks from now, you want to go into a folder, and whatever that folder contains it should be very clear on what you should do. Obviously, when you have a naming scheme that ends up like this on the last panel, you will get really confused on what is the actual cleanest version of either your paper or your code. And so Git is a nice way that handles all of that for you. Essentially, what you see when a folder is Git tracked is the state where the last thing that you ran, everything works. But you still have a system where you could jump back and forth. So you can, have all of these names hidden away somewhere for your own whatever reason. But this way, when you share your project with someone else, they're not completely confused. All right. For those of you who have used Git, this is another reason why you would be here, is to learn how to use Git better. I've been here as well, where you sort of just learn these commands, you really have no idea what they're doing, and when things go horribly wrong, you essentially just delete the whole folder and just reclone it down to your computer, and you start over from scratch. So hopefully this will guide you through some of the Git commands, and so you don't have to do this in the future. The Etherpad over here. Let me just show this link. All the questions should be directed to the Etherpad. It's very similar to Google Doc, where there is a chat window on the bottom right corner, and there is a place for text that everyone can write notes, or I'll post, I guess, solutions on this part. And lastly, the lesson material, if you want, this is actually, I'm borrowing from software carpentry. A lot of the people who have taught for the data-intensive biology are heavily involved or with software carpentry, and so I am essentially just taking their Git lessons for today, which is the version control with Git. If you want to follow along on your own computer, there is a link here for the site where you can, essentially, this is the lesson material I'll be going through today. And since we have this week and next week going through Git, it won't really matter too much if I don't go through everything that's listed here today. We'll do some overflow next week, and we'll teach some more advanced stuff next week as well. Also, on the software carpentry page, a lot of people, when I teach, they always ask, they wish they had a cheat sheet just to follow along. So there is a link here also for reference that will give you a cheat sheet for a lot of the Git commands that we're going to go over today. All right. Any questions so far? Nope. Okay. Don't want that. All right, so there is a very small prerequisite that you have to have coming into this workshop, and that is being able to, one, open a terminal, and at the very least, just be able to go to a folder somewhere using the cd command. I don't think you need anything else, but we'll find out. Since I won't have a whiteboard and I'm broadcasting this, this is sort of a Git diagram that I drew in the past. It looks a little daunting right now, but hopefully by the end of the next 2 weeks or by today, this diagram will make sense. And since I won't be able to live draw, I am going to have to rely on this diagram and this cursor. Hopefully you guys can all see that. Right. So first things first, with Git, you open a terminal. And one of the things I do for Git projects is, because it is a version control system, you would want a good practice, at least that I follow, is in my home directory, I have a folder that's just called Git. And in this folder, that's everything that I know that's version controlled that goes into this folder. What you don't want to happen is to have different projects scattered all over your computer, and you won't have any idea which project is Git version controlled or not. And that will run the risk of, you think something is Git version controlled, essentially you can think of it as a backup. You think something is backed up, but it's really not. And if you were to lose your computer, you have no way of retrieving back your backups. Okay, so to start today's project, I'm going to be in this Git folder, and I'm going to make a folder. So you can, right-click, hit new folder if you want, or if you know your way around Bash, you can use the mkdir command to make a folder. And today's folder I will use is going to be today's date, which is 0406. Once I have this folder, I'm going to go into this folder. Oops. All I've done so far, nothing really fancy. All I did was make a folder and go into it. For those of you who this is the first time you're using Git and you've never properly set Git up before, there are a few commands that you're going to have to run. That is the git config -- global user.name. I'll go into the reason why you need this in a little bit, but essentially you have to tell Git everything that you're doing, and your name and email address is associated with the message that you're writing. So don't write my name, but write your name. So you're going to have user.name, put in your name in quotes, and user.email, and then put your email address in quotes. That's sort of my email address that it's sort of my spam one, so I have that. But remember, this is, depending on which Git system you're using, for many, like at least here at Virginia Tech, most of the labs have GitLab, which is internal and it's not really public. If you work on something like GitHub, all of those are public, so your email address will be public in some way, shape, or form. So that's why I also use this, so my actual personal one doesn't get spammed. But if you have an internal one, you can just use your university email. Another useful command is to set the color, just so you're not just looking at blocks of white text. So there is a color.ui command, and you can set it to auto. And I think if you want to look at everything that you type, just to make sure you got it right, I think it's just -- list, and it will list all the configurations that you have. So at the very least, you should have those two there.
Hey, Daniel, we're going to need a minute to set up
Yep.
people who have not turned up.
So have you're good, right? It's easy when there's just one. Usually there's like 30 people, and something always goes wrong. So.
Could you scroll up a little bit so we can see all of the git config commands? Starting. Yeah, thanks. Okay, I will let you know when we're all set.
Okay.
So anyone who has a question on this, if you need help just getting a terminal, we can help you with that. But once you are there and you have made your git folder, which we can also help you with, so you're going to do git config -- global username, and then in the quotes put your own name. And git config -- global, and in the quotes put your own email, and do this, and you can just say color auto.
So I actually was posting chat box for the questions.
Okay.
So is it intended to be just Linux or Windows Mac OS X by default, or I just wondering, because I have access to the local server and have a Linux installed.
Yeah.
But I'm just wondering whether whether it's this whole workshop is intended, that assuming that you have some Linux system.
You can use Git Bash, right? That's what so if there's a program called Git Bash you can use, and that will allow you to use Windows machine but interact and use these types of commands. Does that answer your question?
I'm asking.
Sorry, what is it?
I'm wondering if it's easier for me to just log on to the Linux server I have.
Oh, okay.
And just follow the examples, or whether I should bother to install the Windows version on here, and it will be no problem.
You could install it. I would prefer to work with it on a Linux system.
Okay. So it's assuming that Linux.
It's assuming the Linux or the Git Bash from this environment. But Daniel just covered that.
Oh, sorry.
Are you doing okay? Okay. Git config -- list. Is that what you did?
Yeah.
Yeah. Cool. So I know this is a lot. This just means that everything is. These are all configurations. Do you have an account on GitHub.com? No. Okay, so I would use probably that over that, but just use your email address. Okay. Yeah, there's our I'm not sure. Are you okay? Sorry, a little late.
If you're using ours.
So, have you used? So let's try there. So I would need to pull. Okay, great. Here you go. And I can go to that folder, and I didn't know you. Okay. And then do the. So yeah, then I made a folder. Right. It doesn't really matter. Right. So then from here you want to do the git config -- global username. Then do the next one, put your email, and then for the last one, we'll just do color auto. And if you have an account on GitHub.com, yes, you can probably work with that. You can get it. Okay. So
well, it was working before, and now all of a sudden I have to reinstall everything.
Okay.
Maybe I don't know why. But I've had this on my machine for a year.
Oh yeah. At least
Yeah.
Are you good in the back? Here, right?
Is Gnome Rasta group at Toronto?
No, it's not. I think he's just watching on his own. And I think, are we ready? Are we good to go? Yep. All right, we're good to continue. Thanks for that.
All right, cool. So right now, we're in this folder. If we look at this folder using the ls command, it's empty. If we look at any hidden files in this folder, it's empty. And so there's nothing really special about this folder, at least not yet. And so the way Git works is for a given folder, Git will track everything from that folder down. And so the way we tell Git, hey, this is a folder that we want version control, that is any change that we make, we want Git to know about. There's a command that says, so all the Git commands begin with Git. And the command we say, hey, start version controlling this folder is called git init for initialization. And you'll get a prompt that says initial Git repository and that link. I realize I should have made a regular terminal, but for me, I have it set up so when I'm in a Git repository, like everything just changes so I can quickly see. But this violent change in terminal prompts is not what you will have, which is sort of my fault. But what you should get is you should get a blinking cursor back and initialized empty Git repository. And if we look at this folder now, again, nothing really different about this folder. But if we look at all of the hidden folders, there will be a hidden .git folder. And so this is how Git knows that this is a folder that's going to be tracked. It's hidden because if you accidentally, select all and delete a folder, you don't accidentally delete this Git folder. So Git is really good about keeping track of all your changes, but all those changes are going to be stored in this .git folder. So if you were to accidentally delete the .git folder, that's when you're in a lot of trouble. But it's hidden, so at least it's a little harder to delete something. All right. So the first Git command that we'll learn after git init, it's going to be your best friend. Whenever you get lost and you have no idea what's going on, chances are you should run a command called git status, and it will give you the status of this repository. In our case, it's going to say on branch master. I'll go over that in a little bit with the diagram. Initial commit, and it's going to say nothing to commit. Create, and it'll give you a little hint. Create copy files and use git add to track.
You don't get this when you type git status.
So, the way this works is you could think of Git as Control S, or the save function on steroids. So usually you'll see when you're on online tutorials, every time you hit Control S to save a document on your computer, that represents a circle in this diagram. And you can go from here, one save point to another save point by doing what Git calls a commit. So think of commit as doing Control S, but it does more than just saving one file. It's really taking entire snapshots of this folder. So Git is really cool in that you can edit multiple files and it'll save all of them essentially in one go. So now that you see this visual representation where you can go from one save point to another, the word master comes from the name of this sequence of save points or commits. So this sequence of commits, so in this case C1, C2, C3, etc., that all has a name, and that name by default or by convention is called master. I believe for today, this is the only thing that we'll work with. So you'll see master a lot, and then next week we'll go into more stuff, and you won't really see master as much. But just for now, just know that a commit is a save point for the entire folder, and you go from one save point to another, and that's called performing commits. And the whole directed acyclic graph, which is what this is called, at least this name right here, is called master. One thing to keep in mind when you are doing or working with Git is because when you tell Git to initialize a repository, it creates this .git folder. It's very tempting to say, hey, you're going to create another subfolder and then tell that subfolder to be Git tracked. And essentially, you will have nested .git folders. You don't want that to happen. That's also another reason why I have a Git folder in my home directory, just because I can always go to that home directory, create a new folder, and Git track it from there. And I'll know it's a clean and clean Git repository. So I can show you, nothing bad will happen if you do end up you create another folder, nothing bad's going to happen. And if you go into this folder and run git init again, Git's not going to yell at you. So if I look at this folder, I'm in another Git folder. It's got a git.git folder. And if I look at the folder above, I have nested.git folders. It's perfectly fine. But this will cause a bunch of confusion and problems later on, especially if you're starting out Git. So that's what you don't want to do. All right, so now that I've created this problem, you can see if I try to remove everything or delete, it's not going to delete anything. Hold on. If you accidentally run the rm command, hidden folders won't get picked up or deleted. So that's another reason why the .git folder is a hidden folder. But if we want to delete this, we can just delete the folder that I just made. If for whatever reason you want to have nested Git folders, that goes into a realm of Git that even I don't work with, and it's for those who are just sitting along and want to learn something sort of new that's not going to be talked about. This is called Git submodules or Git subtrees, and that's all I'm going to say about that. All right. Okay, so all we did was initialize a Git repository, and if we run git status, we have this on branch master initial commit, nothing there. Right? So let's create a file. You can use whatever text editor you want. In my case, I'm going to use Nano just because it's simple, but feel free to use whatever. And so let's have a text called thesis.txt. I'm going to write my thesis. This is my thesis. And I'll have something like introduction. This is a workshop on Git. Right? And if you've never used Nano before, the symbols down here will help you out. Just know that the caret stands for control, and so Control O, writing out, is how you would save this, and Control X is how you exit. And so if we look at this folder, we created a file called thesis.txt, and if we run git status, it's going to say we're on branch master, so we're still on that linear series of commits. We're on our initial commit, so we haven't really done anything yet. And new piece of text that shows up is an untracked file. So we told Git to version control this folder, and we made a change to this folder, and now Git is saying, hey, I found a change in this folder. And the change that it found was this is a file that Git's never seen before.
Is everyone at this point? Do you help? That was a lot of bash. We've never done it before.
I'm personally completely lost, but
okay.
So I'll just go over that last bit again. All I did so far was I went into a brand new folder that I just created just for this workshop. I went into this folder, typed git init to tell Git, this is a folder I want version control. This is this folder and any subfolders that I create within it. So this folder down is going to be Git version control. The next thing I did was, however you want, create a file of whatever you want and put in some text into it. And then after that, I ran git status, and this is the current output that Git is telling me that I've created a new file that Git's never seen before. Right. And if you want to briefly look at the commands I ran, I did git status just to show that it was empty. I created a file. That file existed. I ran git status again.
The point is you can use this for whatever files you have. It's just making a test file, but it's confusing if you've never editor before.
All right. So Git is actually a little weird in that, I initially just told you guys you go from C1 to C2 and that's it. That's how Git does saves. But it's a little more tricky than that. There's this thing called a staging area. So you don't exactly go from one commit to another. There's this whole process of bringing everything that you want to be in a commit into what's known as a staging area. One of the reasons behind this, at least that I can think of, is if you end up making a change in a piece of code, and that code does multiple things, you want to be able to say what you did. Let's say this thing calculated 2 functions, or you did 2 things. You want to be able to say what you did in 2 separate steps. So you can use the staging area to say, hey, this file was changed for 1 step, and this file was changed for another step. So many of you guys who work in a wet lab, this is sort of just like keeping a wet lab notebook. You want every step documented, and you don't want a whole bunch of things thrown in at one big gulp. So that is one of the reasons for a staging area. And to get things into a staging area, you have to add things into a staging area. And the reason why I have add here is because that's the git command we'll be using. So if we look at the status again, we have this untracked file, and we want to commit this file. That is, we want all of the changes from this file to be git tracked and committed. So we can take this file and move it into the staging area, which is using git add. Git add, in our case, we'll just say git add and the exact file that we want to add. So thesis.txt. And if for those of you who aren't very familiar with Bash, you can use the tab key to sort of fill out file names for you. So now that we've added our file, if you go back here, all we did was we were in some magical space and we just added the file to a staging area. And so the next thing to actually do a commit is we have to commit that file. And the command for that is git commit. If you guys didn't set up your configurations with username and user email, I believe this is where you will have an error, and it's going to say, I can't make a commit because I have no idea who you are. So this is why that initial step was really important, because you actually can't use git unless it can identify who you are. Yes. So if you just type git commit without any other anything else after it, it's going to throw you into a terminal-based text editor. For those of you guys who didn't set up which default editor you want, chances are you're in a program called VI, which I will verbally walk you through it. But essentially, if you're in VI, or I think it doesn't matter what program you're in right now, just hit the escape key a few times. And if you are in VI, that is, if it doesn't look like my screen right now with this thing on the bottom, hit the letter I, and you'll be able to start typing. And so every time you make a commit, Git has to know what you did. If you worked in a wet lab, you have to document everything that you've done for a project. And so we can say that this is the initial for my thesis. All right, you can just write a little message to yourself on what did you do. So in my case, I just made the first commit from my thesis. If you're in Nano, you can Control-O, Control-X to quit, save and quit. If you're in VI, hit the escape key a few times, and then hit colon, which is shift and then the key next to the letter L, WQ, and enter. So that's how you will quit out of VI. Jessica, has that been a problem on your end? Do I need to briefly show the Git text to configure the text editor?
You guys know?
Yeah.
Yeah. So.
All right. Let me just show that part then.
Also on Vim, yeah, you need to name the file. It won't let you exit the file. It says here no file name. So you have to show them how to name it, which I actually don't do.
You should just be able to write. It creates a temporary file, and you should just say :WQ, and it'll just write whatever that file is and quit out of it.
Okay.
You don't really need a file name, but depending on which system you are, you can run one more git config command just so VI doesn't pop up again. But I think that's the only time where VI will pop up.
So yeah, go ahead and type this git config global. Okay, we'll do the. I'll let you know when we're all set up with this. Thanks. Go ahead and type this.
Can you see through the transparent terminal? Right.
Not enough, unfortunately.
Okay. You're good, right? Sort of. Oh.
At this stage, I mean, at this stage out of the file when I went to commit, and so I tried to make a new one, so I already broke it. So these are two different files. I'm like trying to delete this one.
Like using RM to delete it?
ARM cache, get ARM cache.
Oh. So that says mistake. That's not deleted.
Okay.
Yeah, that's different. I don't know.
I mean,
What are you trying to do?
File.
Oh yeah, if you just want to delete it, you can just say rm pieces.txt
Okay.
to delete it, and I'll just delete it just on nothing.
Okay, I think we're all set. There's a couple questions in the Etherpad chat, but they've been addressed. I don't know if you want to look at them or not.
Okay. Yeah, I was just out addressing question here. Okay. So the next, I guess, the next thing, we'll just do this whole process one more time, and let me just show the diagram. So all we did so far was we had a file, we added it to a staging area, and we made a commit, right? So I'm just going to go through this whole process one more time, where I am going to use Nano to open my text file, and what's usually after intro? Methods. So I'm just going to make another change to this. And then instead of writing git commit, there's another way you can write commit messages, and it's using the -m command. And the -m just takes a series of quotes. It doesn't matter if it's single or double, as long as you begin and end with the same. And just like if you just type git commit without the -m flag, you can write your message directly here. So this is useful for if you just need to put in a quick one sentence on what you did, and you don't have to write like an entire paragraph or explanation of what you did. You can write git commit -m and write your message directly. So this will go around the problem of if you didn't have Nano set up and VI is your default and you have no idea how to change it. You can do this from this point on. So added methods. Whoops. What did I do? Nano thesis git commit. All right, so I edited my file and I wrote git commit directly, and it's going to still say changes not staged for commit. So what I tried to do, or what I thought I did, was I thought the file was in a staging area, and I wrote commit, and it's going to say, hey, I couldn't really make a commit because nothing was added to the staging area. That is, if I look at status, it's going to say changes not staged for commit, and it's going to give me a prompt that it's red, telling me that it's not in the staging area. So let's fix that problem. So I'm going to say git add thesis.txt. I look at status now. It's one, the prompt is it's going to be green, and it's going to say changes to be committed. That is, this is a file that's in the staging area and it's ready to make a commit. And so now let's do this commit, git commit -m added methods section. Okay. You can see I use single quotes this time. It's totally fine, single or double. And now what you should get back is the word master. So this is where we got the thing from. Don't worry about this right now. The message that we wrote, and it's going to say we changed one file in this commit, and there were 5 new lines added. So if you remember, I didn't just add 1 line when I made this change. I hit enter a few times and typed 2 lines of text. So far I've made 2 commits, and if you want to look at what you've been doing, so let's say, you know, you're working on a project today and you're going to go on vacation tomorrow, and then you come back a week later and now you're back at work and you just want to know, where did you leave off? Because you've been writing these messages to yourself, a good way to know where you left off is just to be able to look at what messages you wrote. So the command for that is git log. And so when you type git log, it's going to give you a reverse chronological listing of all the commits that you've made. First, every Git project will have every commit in a Git project will have a unique series of letters and numbers that represent that a specific commit. And so this is known as the commit hash. If you ever need to refer to a very specific place, you just need to find this commit hash and you'll be fine. This is actually unique enough that you really only need the first 6 or 7 to refer to any point in history. So you don't have to use the whole thing. Next is going to say the author. So this is the initial part where we put in our config, who you are and how to contact this person. Git was originally made by Linus Torvald when he was developing Linux. So Linux was not just a one-man thing. There were multiple people contributing to Linux. And so you can see that Git is a really good collaboration tool because you can track who is doing what at any given time in a project. And we'll have the date just for good measure. And the last thing is the commit message that we wrote. Right? So you can use this git log command to get a listing of everything that you've done. Chances are when you are looking at the log, you really just want to look at, you know, the commit message, and you don't need all this extra information. And so a very common parameter that you can give git log is -- 1 line. So you're essentially saying, hey, I don't need this like multi-line output. I just want the 1-line version of this. And all it will do is give you the first 7 letters and numbers for the commit hash and the message that you wrote. And it's only going to be the first message in your commit message, the first line in the commit message. And so if you have like a long project that has thousands of these things, you know, you just need to look at the 1-line version and you'll get a good sense of where everything is. All right. So the next thing, so there's multiple, so we'll go into next on what other things you can do when you make changes into the Git. So let's edit this file one more time. So I'm going to use nano for thesis, results equal. Right, so I'm going to edit this file one more time. And so let's say you come back to your desk from lunch, and the good thing is to always type git status to see what's going on. So just a recap, if I run git status, we're on branch master. So that is just the name of all the commits that we've been making. It's going to say changes not staged for commit. So before it said, what did it say? I think, I I have no idea what it says. I think before it said new file thesis.txt, but since we've already made a commit on this file, it's going to say modified instead of new file. So it's going to say Git's going to help us as much as it can. So it's going to say git add file name to update what will be committed. If you want to undo any changes, you can run this command. But let's say you come back and you run git status, and all of a sudden you see a file that's red, and that's not something you expected. Either you probably forgot you made a change before you left, or you just didn't commit something before you left and you just forgot about it. And when you're working on either a thesis or any piece of prose or software code, it is a little scary when all of a sudden this thing is saying that there's a change made and you're not aware of it. So how do you see what that change was? There is a git command called diff, which just says for any of the files that have been changed that Git knows about, that is when the words are red, just tell me what the differences are. And so this is the type of output you'll get from git diff. It's going to say diff. There's going to be two versions. The original version, the last committed version that Git knows of, and the current version, which is the version that's been changed some way that hasn't been committed yet. The next few lines, this line I believe refers to the commit hash, but I could be totally wrong. I don't think it's really relevant. But let me think. Yeah. So if you scroll to the bottom of the git diff results, you'll see in green text with pluses, which is saying these are lines that have been added to a file. If you see red dashes, that is lines that have been deleted from a file. And that is the difference between the last committed state and the current state that you're in. So if I run git diff and I see results, people learn Git, it's awesome, I can immediately know, oh yeah, that's what I just did. And that's something that makes sense. I just temporarily forgot that I made that change. Right. So this is a change that I want to keep. So let's git add this. There's another shorthand for adding. If it's just one file that you're adding, you can use the period. Essentially what git add period does is any file that's been changed from this folder on will automatically be added to the staging area. So if you have multiple files that you've changed and it all represents one thing, you don't have to type in every single one of those files that you've just made a change to. You can just say git add period and it'll add all of it. Just to prove to you, we only have one file here, but if I say git add period, it did the same thing. And it's going, and if we run git status, it's going to say we're on branch master, nothing new there, and a change ready to be committed, and the file is in green. So those two words are a prompt for you to saying, hey, this is a file in the staging area and you're ready to make a commit. And so we can write git commit, and we can say wrote started false. So we added 4 lines and we changed one file. If we look at git status, it's going to say we're on branch master, nothing to commit, working directory is clean. So usually before the end of the day when you leave, this is probably what you want to see when you run git status, meaning that everything that you've done has been committed. In other words, saying that this is a snapshot in your folder that you can always revert back to. So you can think of it as like it's been backed up. Okay. So let's edit this file again. So you'll see that this adding, committing, this is actually the whole crux of using Git. It's this process of you make a change and you have to manually add and commit. The first time you're working with Git, it's going to be really annoying, like why is there this 2-step process? But when you start working with other people, or when you start working with anything that's really important that you want backed up, it is actually worth a lot of the additional 2 commands so far to just save it. So let's make a change to this file one more time. So let's say I'm just at work and I am editing this thesis, so I have results, and the last section is
If you're using there, what would you take?
is a good discussion point. You should use Git for anything important. Okay. So edit this file one more time. I can say git add period, and I look at git status, and let's say I add it, and then I add everything, and I look at status, and all of a sudden I see something that's in the staging area that I'm not really sure why it's there, because after a while some of these commands just become like muscle memory. And so you run git status and you see something that you don't expect, and you're like, oh, what is the change for that file? And if we run git diff, because that's the command we just learned, it's not going to give us anything. And we're going to be a little confused where we know this file has changed, but when we run git diff, it doesn't give us a difference. And I don't exactly know the reason behind that particular behavior, but there is a special command that you can give diff that's saying, hey, find a difference, but look at the difference for everything staged. So we can say dash dash staged, so find the difference of everything in the staging area, and that'll give us the same git diff back. So in this case, we've added this series of lines. All right, so right now I'm going to look at git status. It's actually pretty good if you make a typo that'll tell you, like, did you mean this? But it's not good enough to actually do it for you. So we're going to look at git status. This is something in the staging area, and we'll need to add it. We can make the commit directly, so add right. If we look at status, after we make a commit, everything's committed, working directory is clean. Great. So the first challenge I'll have everyone do is create a new file. Let's call it bio.txt, and write a one-sentence bio about yourself, and then add the file to the staging area, commit the file, look at the log. Great. So yes, 1:15 I think should be enough time. So I'll give you guys all 5 minutes to do this, and I guess Jessica, let me know when everyone on your side is done.
Yep, okay, I will. Okay, we can do this together if you guys would like, or you can go on your own. If you want to follow along. So the first step would be just to make a new file. He's been using Nano, but you can use Notepad or whatever, text edit, whatever editor you want. And then once you're there, you go through the adding and the committing. And if you want to do that and you fix steps, then just let me know. And I can help. If you just want to watch, that's fine too.
Are you good? Sort of, maybe? Yeah.
I'm good.
Okay.
I'm good. Yeah.
I'm guessing you've used this before?
I've never used Git.
Are you an SVN person?
No, I'm like, I have a computer science background. I'm
Okay.
self-taught.
Yeah, so am I. That's like everyone.
Yeah, so this is pretty new. It's perfect time though. I literally the day before I saw the announcement, I was just saying, I
Oh.
can figure this whole thing out.
That works. Okay, so yeah, it's a little weird that you're the only one here, and like I'm like waiting on other people, but hopefully the pacing is like okay. If you ever get confused, I guess you can just yell at me. Okay. Oh, that is this git config dash global core.editor, and then in quotes you can write nano. I don't know what the dash W is, but I guess enough people have. I guess it's there for a reason, so you can put dash W. Yeah. And this way, when you just type git commit, it'll just throw you into nano directly.
Nano core editor.
Core.editor, and then nano-w in quotes.
Yeah. I should say which file it is. There's a way to search the actual commit, and it'll show it. Okay. That would be a good question. So I just put it right in the chat.
What's the difference between GitHub and GitLab?
Oh,
Are they using the same system?
so I'll talk about this I think at the end of today, but essentially Git is the core, Git is the thing that's doing the version controlling, right? That's the thing keeping track of your work. GitHub and GitLab, they're just other servers that can think of it as another backup. So you've done backups on your computer by using Git, so you can accidentally delete a file and can undelete it. But GitHub and GitLab is just another place to store it. So let's say you lose your laptop. Now, because it's on GitHub or GitLab, you can still download it back. That's really it.
Is this something like a cloud? Or?
Yeah, you think of it as like it's the cloud that stores Git information. That's really all it is.
This one is just like a backup.
Yeah, local backup, and you can think of GitHub as an external backup. GitHub and GitLab and all those other cloud things, they have nice other features that I'll show you. For me, I use it to do project management. So instead of keeping a notebook of what I need to do for a project, I just do all of the notes in that system.
Are these two like totally we have different functions?
No, they're the same exact function. GitHub is a company, is a company, and GitLab is a company. It's the same thing, just different companies sell a different product. So things look a little different, but the function is exactly the same, and the words that you use are exactly the same.
So I was thinking like GitLab is really like you can do it to like collaboration, right?
Yeah, so is GitHub. Yeah, so the main reason why there is a difference like GitHub and GitLab is GitLab is something you can install on your own server. So let's say you're in VBI, you don't want or you're in a hospital, you don't want your stuff going to some random server in the cloud. You want this thing to go on the server in your own building. Or like VBI, we want all of our stuff in the VBI servers, not on Amazon. Then you use GitLab, right? Versus GitHub, I don't really know where GitHub servers are. So it's really like if you have a privacy concern, you might use GitLab. GitHub by default, everything's public. So if you don't want everyone to see what you're doing, let's say you're working for a company and this is proprietary code, like you're not ready to release it for everyone to have, you would use GitLab.
I mean, can you implement access control on GitHub?
Yes, yeah, you can.
Why still? I mean.
So for GitHub, if you want it to be free, then it has to be public. If you want it to be private, then you have to pay for it. There's another system that's exactly flipped, which is if you want a private, it's free, but if you want a public, you pay. So if you by yourself, between the two, you really don't need anything. But yeah, they just look different. There's little differences, and depending on which difference you like, you'll pick. But essentially, all the same. Are you guys good on your end? Sorry.
Yeah, we're all good to know. There's been some questions in the Etherpad if you want to go through them.
Okay, let's see.
You can go after.
Oh boy. Okay. Do you know which question I'm looking at?
There's the questions at the bottom, I think. A lot of them have been answered by other people.
Oh, can you also create a private GitHub repo on Bitbucket? Oh, that is a statement, not a question. Nothing to commit working very clean. Given this, assume I'll say everything that's there are X files. Yeah. Okay. So let's. So I'll just go through the exact example that I told you guys. So I'm going to create a file called. So let's look at status right now. So nothing to commit working directory is clean. If I make a file called bio.txt, say my name is Daniel, I am a student. I realized I didn't introduce myself, and you guys are all listening to me over some way through the internet, and so this is who I am. So if we run git status, you'll see that Git will say this is an untracked file, versus before the past couple of times when we've been working with the thesis file, it's going to say, what will it say? Changes, not changes to be committed. It's going to say changes not staged for commit, right? So to answer the first question that I see, if you do see the words nothing to commit working directory is clean, you can assume that every change that's happened from this folder, from this point, or this repository, every change has been saved and logged by Git. So you can make that assumption. What did I tell you guys to do? Write one sentence, add a file to staging area, and commit it. All right, so I look at status. It's saying that it's an untracked file. I can add this either by using period or directly typing the name. That's really up to you. And then I can write a commit saying bio about self. And I think the last thing I told you guys was look at the log. So git log. If you ever run git log and you have, so right now we've made a few commits already, and you write git log either in one line or just the full form, and there's more information the log has than fits on your terminal screen. You'll know that you can scroll up and down using the up and down arrow. It actually opens into a terminal program called less, and the way you quit out of less is hitting the letter Q. And you'll know you're in less because there's going to be a colon and a blinking cursor at the bottom left corner. So if I hit Q, I'll exit, and I can do my regular Git stuff. So let's look at this log. So again, it's in reverse chronological order. So the first thing on the top is going to be the bio about myself, and the last thing was the discussion section. So you can see that it doesn't really tell you what file you're editing, but just given that one sentence should prompt you enough to know roughly what's been changed.
Can you get a log for each individual file?
I think you can get a log for each individual file. So git log, and I think if you just give it the file name, it'll just give you the log for that file. All right. So up until now, all we've done is we made a whole series of commits. And you're always going to be at the latest commit that you've made. So I'm going to show you how you can sort of look back in time or undelete a file, for example. So where you're pointing at is what Git refers to as the head, H-E-A-D in all caps. So that's where you are in that folder. So every time you make a commit, you, for example, go from C1 to C2, the head moves from C1 to C2. So now you're looking at C2, which is the latest version of everything that you're, which is the latest version of your repository. And so, let's say, for example, let's look at this, git log -- 1 line. All right. So it doesn't really tell you where head is right now, but we can, at least for now, we can just say we know that we're at the very top. We haven't done anything weird. And let's say, for example, I wrote this discussion section, and I want to compare what this discussion section or the text for the thesis is from the first time we looked at it, right? So we know that git diff compares two files. Let's say we want to say we're here and we want to compare a file from here to the very beginning. We can say 1, 2, 3, 4, so 4 time steps back. We can say head ~1, so whoops, I say 1, 2, 3, 4. Head ~4. So from where we are, which is head, 4 steps back, and we want to look at the thesis.txt. And this will give us the diff of our current file and 4 steps back. And you can see that from now to from 4 steps back, that's pretty much the entire file that we were looking at. Again, because it scrolls off the screen and you'll see the blinking cursor in the bottom left, you're in a program called less. If you want to quit out of it, hit Q. If you want, you can also just say, just give me the entire difference from now 4 points back, and you'll see that it'll give us io.txt, because that didn't exist for commits before us, and it gives us the same change as before for the thesis.txt. But sometimes if we look at the log one more time, let's say you want to go like 17 steps back. It doesn't make any sense for you to start where you are and just start counting 17. So it's easier to see this is the point you want to go. And now instead of saying 1, 2, 3, 4 steps back, you can just use the commit hash that's printed right next to it. So again, that commit hash is unique to that point of the of your repository. So you can say git log. Instead of head tilde something, you can just put in the commit hash. So my version of the commit hash will look different from yours, and it doesn't have to be. This is actually the first time where I've only seen numbers, but it's usually a combination of letters and numbers. And the first, I think, whatever they print out is more than enough, and you don't need like the whole 20 plus characters. So I can say git log, oh, not git log, sorry, git diff of that commit hash, and that's the same thing as typing head tilde 4. Now we have a quicker way to like, hey, quickly search where we want to go and then sort of take a peek. So if you are like, for example, writing a piece of code and you make a commit and then all of a sudden your code doesn't work, and you want to just compare your current version with the version before, you can use the log that you wrote or the commits that you've written to pinpoint where you made that file change, and then just do a diff between the two. Maybe if you're in Python 2, for example, and you forget that integer division will give you an integer result. So like 9 divided by 4 is 2, not 2.5 or 2 1/4. Ooh. Yeah. You can use this as a way to figure out like, oh yeah, this is the only line of code that I've changed, and this is probably where the problem is. So you can use that. So notes for commits. There's an XKCD on it, just like many good things that are scientifically related. Don't write commits like what he has on the bottom. It's really easy to start, being really good at the beginning of a project, and then towards the end, it's just like commit 1, commit 2, etc. You want this to be at least a little bit informative. It will, if you're just chugging along, it might not make too much sense while you're just writing a message. But you can describe what you just did in a few words, and it will save you in the in the long run when you have to look back and compare pieces of code on what you did, right? So, yeah, hands. Great. Give me a second. Just need to make sure I am. Okay. So let's look at our status. So right now everything's clean. There's no changes. Let's look at. Let's make another change to bio.txt. And I'm going to add something here to my bio that's not true, which is I have totally not true. Still working on it. And so let's say we see this and we run git status and there's a change, and if we look at git diff, we're saying that, hey, that's a change that I see. That's nice that I can compare, but that's a change I don't want. If this is, if you're writing a paper, if you're writing a piece of code and you write something and all of a sudden everything went horribly wrong, and you sort of just want to undo everything. So right now, where's my? Right now, before we had a commit, so let's say we're at C1, I've made a change. So nothing's really in the staging area, but head is still pointed at C1. So we're in this weird place where there was a commit, we've made a change, and that's it. So if we want to just revert back to, just reset everything, there's a command called checkout. And what checkout does is, checkout is the command that takes head and moves it to a different point, right? So we can say, hey, check out head and check out head, like check out where head is, which is saying, hey, turn the whole repository and make it to where head is pointed to. And since head is always pointed to a commit, that's one way that we can just undo everything that we've done, or undo a file change. So let me just show you that. Git checkout. So checkout is a command to just move around or change the state of a repository and point it to a different point in time. And we can say, hey, checkout head of bio.txt. Now if we look at status, it's going to say nothing to commit, working directory is clean. If I look at what's in bio.txt, you can see it undid all of those changes. So, your cat jumps on your laptop, a whole bunch of things happen, you have no idea what's going on, but your last commit was good. You can run git checkout head of a file and it'll just undo the changes for that file. That also means if you, for example, delete a file, so remember rm in bash world means delete forever, not move something to a trash can. This is, I'm just going to delete it. So let's say you accidentally delete a file, you can actually say git checkout head bio.txt. This actually might not work. Okay. Didn't have complete. But yeah, if you accidentally delete a file, you can use the checkout command to undelete a file. So there is one of the mantras for Git, which is just commit early, commit often. Oh, it's not commit early, it's branch early, but I'm not going to talk about that. It's just commit often. So every time you are in a point where everything is good, make a commit, because there's going to be, something bad can happen, and this is just like a reset. Let's say I delete everything, for example, and I look at status and it's going to be like, hey, you deleted these files. That's great. How do I undelete them? So Git's actually really good to know, to see that if a file's been tracked and it gets deleted, a delete is actually a commit. So you actually have to be very explicit even if you want to delete a file. But let's say we want to undelete these files. We could use git checkout head and list the files, but my version of, if there's a lot of things that happen and I really can't figure out what's going on, there is a command called reset, git reset, and the parameter is --hard, which just means, hey, I don't care what is going on, just revert me back to the last state. Right? So that's a way you can just totally undo everything that you've done and just go back to the last commit. And you can see that's how we undeleted a file. Okay, so right now I'm going to show you what it doesn't seem, especially if you're programming, this will probably be the, no, I still have some more time. So especially if you're working with code bases, you're not going to just work on one file at a time. Chances are you work on 2 files. So I'm going to make a change to both of these files. So nanobio.txt. I am hoping I'll make a change to bio.txt and make a change to thesis.txt. I don't know, what else is here? Abstract. Look at git status. I made a change to both of these. And if, you can use git add period. I look at the status, it'll add both of them at the same time. You can do this. I've done this too. It's just easier sometimes just to add everything and just talk about it in a commit message. But if there is, for whatever reason, you want to break this up into multiple parts, let's say there's 15 files that you've changed, but only one of them isn't relevant. One thing you can do is just add all 15 and just unadd one of them. And so the way you can unadd one of them, Git actually tells you right here, use git reset head file to unstage. Right? So this isn't reset as in like, hey, just revert the changes. You have to say reset head and then add the file name. And what it will do is both of these files right now are in the staging area. And if you use reset head and the file, it'll just take the staging area and just pop it back into unstaged, in the unstaged world. So git reset head bio.txt. And did I mean reset? I was going to say unstaged changes after reset is bio.txt. That's good. That's the file I told it to unstage. If we look at git status, you can see that this is the first time you're seeing this much text dumped out, but it's going to be, we're on branch master, so nothing new there. We have changes to be committed, so that is, these are the files that are in the staging area. And at the same time, changes not staged for commit. So these are files that are not in the staging area. So we've successfully unstaged a file. So you don't have to commit everything at one go. You can have like a working file that's just, a configuration file that you're constantly tweaking, and you don't need to make a commit every time you're changing your code. You can just make commits to your code, and maybe at the very end of the day you'll commit the configuration file or something. So not everything has to be committed, but you won't get the magical like working directory clean message if you have files that files that have been changed that haven't been committed. So now that we have thesis in the staging area, we can commit thesis, which is git commit add abstract. Look at status, we're on branch master, and all that's left is the bio. So now we can separately add bio and then commit the bio, which is talking about when. I look at the log. You can see that what I did was I made a change that were really 2 distinct things, and I can still add them separately and have a nice running log of what I've done.
Hey Dan, there's a question in the Etherpad.
Okay. Yes, you can check out. You can use that. So, wait, is that the question that I'm looking at or trying to answer? How do I check out 3 steps back? Yes. So let's say I want to check out this file of 3 steps. 1, 2, 3. Right here. So you can use git checkout. Don't type this. Let me just show you what this does first. Head ~3 of bio.txt. So this is a command we can write. So let me show you what bio.txt looks like right now. And after I run this command, whoa, what's going on? Did I forget something? Oh. Now I'm confused. Head.txt. Oh, I can't do ~3 in my case because that file doesn't exist back then. So let's do -2. There we go. Now if I look at this, you can see that the file actually got changed back to that version. So this is sort of me undeleting or unmaking those changes. If I look at status, you know, that file has changed. I made a commit where those lines existed, and I just told Git to revert back to a previous state. But because it reverted back to a previous state, the commit it's coming from, or making the difference or the diff, it's still different. So any change you make to a file, Git will see it, and you have to log it. So you know, you can do what, as long as you're making consistent or frequent commits. Once you make a commit, that's always a version that you can fall back on. So even if you delete a file, revert a change to a file, you can always get that state back. So if I look at the diff, it's git diff -- staged. It's going to say, instead of, so far all we've been seeing are green lines, but this is saying, hey, you actually deleted this line. I didn't go into the file and delete it. I told Git, hey, revert the file to this previous state. But the way Git sees it is it's just comparing 2 files, and this line is different in the current version. Yeah. And if I want to undo this, git reset -- hard is usually what I do. And that file goes back to normal, or it just goes back to the last commit. Any other questions? Are there any other questions I'm missing?
No, I think you're good.
Okay.
I have any in the chat.
So if you've ever worked in Python, you'll notice that sometimes when you run a Python script, there's some .pyc comes out. If you've worked in LaTeX, you know that when you try to compile a LaTeX document, a whole bunch of other random stuff gets created that you really don't care about or you ever look at. And so when you're working in Git, a common practice is you really only commit like the regular source code. Things that get generated, you typically don't commit. So what I do is, if I I'll commit in, if it's not a very large data set, I'll have a data set in my repository that's saved in a data folder. I'll have a separate script that analyzes that data, but any plots or any temporary intermediate data sets that get generated, I want those to be ignored, because I know that the script is good, and if I need it, if I ever need it, I can just run it and it'll just regenerate again. So things that get generated typically shouldn't get tracked. They really don't need to get tracked. Again, there's always going to be exceptions. So what you want is you want Git status, and when you look at Git status, you want to see there's nothing to commit, working directory is clean. But now if you run, like, if you try to compile a LaTeX document, there's going to be these 6 files that get created, and you don't want them committed because they're generated, and it's really annoying to constantly like delete them manually after the fact. And you want to like leave at the end of the day knowing that everything is good. So Git has a mechanism that will just blatantly ignore files that you list. So let's create some files. You can use the command called touch to create files. So I'm going to say file1 dot log, file2 dot log. Right? So all I did was create 2 files. Git knows that those are 2 files. But let's say those are 2 files that just get generated because, you know, I opened bio.txt. You know, if you any text editor, there's always going to be either a hash or a tilde at the end, and those are like those recovery files. Like, you want to ignore those. Those actually, like, why do you need to start Git tracking recovery files? So you want a way to ignore them. And the way you ignore files in Git is you can actually, how should I? Yeah, make sure you're at the root of your repository. So in this case, it's easy. We don't have subfolders, but go, if you do have subfolders, go to the beginning where you see the .git folder, and you're going to create a file. And this is a really special file that Git knows to ignore files, which is called .git ignore. Right. So you make a file called .git ignore. And in here, you can either name the file, so you can say file1.log, as in that's the file you want to ignore, or you can use bash wildcard and say, hey, ignore everything that like ends in .log. Right? You can specify it either way. Now, if you save this file and you run git status, you'll see that those files that the ignore file contains won't show up anymore. Again, I just created an ignore file, so Git's going to be like, hey, there's this other thing that I've never seen before. Yes, this is something you want to commit, but all that other like temporary output or backup files, they're not there anymore. So we can add the ignore file, and then we can commit the ignore file. Create ignore. Right. So this file, if you know what type of project, whoops, that's not what I want. That's not what I want either. If you know the type of project you're working with, so a LaTeX project or a Python project, you can actually just say LaTeX git ignore. Type it in Google. There will be a centralized place, so everyone has these problems, and so there's like a nice curated list of .git ignore files. And so you can either, you know, what I do is I click the, so this is in GitHub, which I'll show you in a little bit, but you can, there's this whole repository of git ignore files, and that's, you know, pick your language or thing of choice, and it's probably here. So Python is in here, so there's a Python git ignore file. There's an R, if you just saw it. There's an R git ignore file. It's not called LaTeX. I think it's just under tech in this case. And so you can see like these auxiliary files, log files that get generated by tech. You know, someone's put together a lot of time. Like, apparently this is potential stuff that comes out. So what you can do is click the raw button and copy paste this list into your git ignore file, and then now you just have an ignore file that should pretty much ignore everything related to weird stuff from LaTeX and or Python, so you can do that. And again, as your project grows, you add more and more stuff to the ignore file. It's not just like, hey, you copy and paste it once and it's forever. You're going to have intermediate data files that has your own naming convention, write a pattern that matches that naming convention, and you can ignore it. All right. Okay, so we'll take a break. That's pretty much, let me just show you the image. So everything up until now, this is working with Git on your local computer. So if you just want something to back up on your local computer, this is the bread and butter of Git. Adding, committing, occasionally you want to look at the log. You're pretty much typing Git status all the time. And you can use checkout to kind of just go to a magical place. If you do, for example, type, let's just, this is going to be something that people might do by accident, is you're going to, for example, oh, I want to like just look, instead of typing git diff or something, you end up, you know, checking out, instead of the thesis.txt, which is just reverting the text in this file to that version, you just type in the hash. You're going to have this giant output, and you know it's going to say something really scary, and it's going to say, hey, you're in a detached head state. You know, like bash is a really violent place, and it's going to say Git actually does a pretty good job at telling you what you can do. The trick is, you know, trying to understand what it's trying to tell you. So right now, if I look at Git status, it's not going to say we're on branch master anymore. We're actually just looking at, you know, whatever our folder structure looked at, like at, in my case, 4617372, right? So we're not really anywhere, but we're just looking at that point, at that version of our repository. And it's going to say you can look around, make experimental changes and commit them, and you can discard any commits you make in the state without impacting any branches. Essentially, you can do whatever you want. You just revert it back to a state. You can do whatever you want, and you know you can go off from there. I don't read too much into the next few lines. We'll go over that next week. But if you are ever in this point because you forgot to put a file name, the way you can go back to where you came from is saying git checkout. So remember, checkout is how you move where you're looking at or what your state of the repository is. So you can say git checkout master, and this will just bring you to the tip of master, which is the last thing that you did. So if you ever type something wrong and you're in some weird place and you have no idea where you are, chances are git checkout master will just bring you back to where you should be. All right, so the last recap. So everything we've done now is how you work on Git on your local computer. This is great as a local backup. So you delete a file by accident, you have a way to undelete it. But this doesn't solve the fact that, let's say your laptop just blatantly breaks or it gets stolen. You can't use Git to sort of undo that. It doesn't work that way. And so now we want a way to say, hey, take all the stuff that we have on our local computer and just send it off somewhere as like a backup. And so everyone from software carpentry, we teach a system, or not a system, there's a thing called GitHub. Hopefully you guys have heard of it. Essentially, GitHub is a server that exists in the internet, and you can take the Git repository that you created on your local computer and save it on GitHub. The thing about GitHub is if you, by default, everything is public, meaning that anyone and everyone can go to that version find your repository on GitHub and have full access to the source code, the commit history, et cetera, et cetera. So if you you know, aren't really paying attention and you like hard code a password in your in your light code for whatever reason, someone could potentially find that. And so, keep that in mind. This is completely open to the public. If you want a private version on GitHub, you have to pay for it. But there is a system called Bitbucket, which is the exact inverse, which is by default everything is private, and if you want something public, you have to pay for it. Both systems, they look different. Pretty much everything I'll show you through GitHub will transfer over to Bitbucket. Here at Virginia Tech, certain labs, they have a system called GitLab. And so the rationale behind GitLab is GitHub and Bitbucket, those are servers somewhere on the internet. And for security purposes, a lot of places just don't, they want to know where this server is, and they want full control over the server. So GitLab is just a system just like GitHub and Bitbucket, except you can install it on whatever machine you want. So a lot of labs have a dedicated server that they have a GitLab set up, and that's where you will be sending your code from your computer to. So all three systems, there are a bunch more as well, but all three, they all do the same thing. If I teach you GitHub or show you GitHub, they'll transfer over. And so we'll take a 15-minute break, and if you haven't done so, go to GitHub and make an account.
Really quick, Dan, sorry, could you answer, there's one question in the bottom of the Etherpad in yellow. It's the third thing from the bottom, but yeah.
I gotta find it. Hold on. If I rename a file, is Git's able to make a diff between before and after? I don't know if you rename a file, actually. Let's do it and find out. So let's rename bio.txt, so not remove. Move bio to bio. If you do Git, so first, if you rename a file, chances are when you run git status, essentially bio.txt disappeared, and now you have this new file called whatever you renamed it. If you run git diff, it's going to show you exactly that. This file got deleted, bio.txt got deleted. And so that's why you're going to see bio.txt, everything is red. Bio rename was never really git tracked, so it's not going to give you a diff on that. But if you ever rename a file and you run git add, for example, Git actually will know that, a file didn't get deleted and a new file got created. It actually got renamed. And so if you run git diff -- stage, you'll get the diff for both things, which is this thing got fully deleted and now you have this new thing, new file. So you can use MV to just reset everything. Good. You can use MV to directly rename a file. If you want, you can use git mv.txt to bio rename, and it will just do that thing for you in one step, so you don't have to do it in two. But I most of the time I forget to write git mv, and I just write mv because of a bash script or whatever. And it either way works, and you can still get a diff, but you can only really get the diff if they're staged, and Git will know that it's a file that's been renamed. Cool. I think that's it for questions. So 15 minutes, so 2:10, I think. And let me, if you have not done so already, GitHub account. We'll resume. GitHub 2:30 p.m. Eastern Standard Time. I don't know what time it is there.
That's fine.
11? Oh no, not 30. Whoops. 2:10. Whoops. 11:10
Yep.
Pacific Standard Time.
Yeah, and you have
AM.
an already.
Okay.
Yeah.
And I'll just monitor questions until then.
Okay, sounds good.
Yep.
I have to leave.
Yeah, sure.
Early, unfortunately, but for when you're done, you do get status that says working directory, you can just exit out of the terminal, or is there like a way?
Yeah, that's fine. Yep.
No official sign off for?
No, yeah, it's there's no logging out or logging in or anything. It's just whenever you're in there, yeah.
Okay.
It's not that kind of.
And to get back in, you just change the directory to that.
Yeah, whenever you're in there and you make a change, then you add the change. Yeah, so it's kind of it really does track every change that you make. If you just go in there, it's not going to know that. So
Right.
it's not monitoring that, but yeah, any change that you make, it will.
I would argue this is advanced beginner.
Yeah. Yeah, so is there another one next week?
Yeah, it's going really fast.
But it's okay, I guess. It's on April 15th.
Okay.
The 11th.
It's 13th. I think it's just next Wednesday.
Yeah, you can register, and I'm curious to see he's just covered a lot of material very quickly.
Yeah.
You know, because when we teach this in software carpentry, people have already that we've already done a whole 3-hour section on the bash terminal.
Okay.
People are used to that. You know, they know what the text editor is.
Right.
Already.
And this is the second session. It's in the afternoon, in the morning, you go through shell and get used to navigate files.
Yeah, maybe. Yeah.
Okay.
Yeah. Good resource. I think. The eager pack is really good this time.
Yeah, I like it.
Yeah, people are using it.
Thank you. Yeah, that's fine. Oh, I should let you know, the people at the integration desk do not know what the DSI space is.
Really?
They don't.
They're like, there's a password I think.
Yeah.
I just need to know, like, wait.
Okay. Good info.
Yeah.
It's on the map, not yet. It's a cultural change.
My link for the map, for whatever reason, today also wouldn't work.
Oh,
So I
you
just
did?
remember seeing DSI
Yeah.
share
yeah.
space, and so.
Yeah, navigating this campus is so hard, in my opinion.
Some people left. Oh, there's a break right
Okay,
now.
no, it's one.
But one person left. I'll be leaving. I think we'll only have a couple left. It's way too fast for me. Completely lost. At the very beginning, I was lost.
Can you,
And it's only gotten worse.
and
So
can you interrupt them, or is this?
you can interrupt them, but it's not, I don't think at this point it's gonna matter. It's not gonna be any good. I'm too basic.
What's your background? Which university student?
Yes, ecology. And I use RStudio, but I've come to 3 workshops for Git, and all of them have been introductory, beginner, and they just dive in so fast that I'm completely lost within the first 20 minutes.
There is one coming up on Friday. And I think that might actually be a good one because, so Titus organizes these things in the
software partners and stuff like that. There's another guy called Carl Stainer, who's over there, who's going to be doing one. He's doing it kind of for English students, social science students.
Oh, even better. For me, it'll be really basic.
An introduction to the command. Oh, that's nice. But that's.
Well, I just mean that like they're just different. That sounded not the way that I meant it to.
I agree.
They generally use different platforms.
No, exactly. So it will be very knowledgeable. So he's doing some workshops on text mining.
Okay.
And this is the precursor to that, basically to get people up and running with the command line. Git.
Okay.
So it will be very basic.
Okay.
Intentionally very basic. So if you're interested, that might be right.
Where
Where did you find out about this?
Yeah.
Well, you see, so do you know where you are?
Yes.
Well, where are you?
The DSI shared space.
So if you go to dsi.ucdavis.edu, if you go to dsi.ucdavis.edu, there's a mailing list, there's also this. That's in there. There's a list of all the workshops and stuff.
Oh, okay.
So what happens? So he's doing separate. Carl's doing separate. I'll have one. Graphics.
Great.
On the way there, but that's pretty defined list of facts. There was a mailing list.
Cool.
Okay.
Great. Thank you.
Good. Okay. Okay. I'm gonna go on. You handle it.
Ooh, there's the ultra basic introduction to the command line in Git. That's what I need. Ultra basic. That's this Friday. I think.
The DSI office hours?
April 8th, 9 through 12. April 8th, 9 to 12. You said this is going to be very basic. So, there's no information on registering, so I wonder if you just. Because here, you actually have information about where you could go, but this is nothing. Maybe I just show up. I can.
Right.
Yes, that's right, I'm here. That's me.
Yeah, I think the DSI folks on Friday is like an office hour, so maybe this time
Yeah. Yeah. Nice.
there's another Git tutorial on Friday.
He says it's much more basic, more elementary.
Yeah.
But there's no information on actually registering, so I wonder if you just, because a lot of other ones actually have
Yeah.
registry or information you can go and register. It's not, so. Yeah, it could be just that they're doing that at the same time as their office. You don't have to register. Great. Maybe I can work that, because I don't work until 12:30. Okay.
Yeah, and then when you see it all again, it'll make a lot more sense.
I hope so, yeah.
Yeah, the first time I started learning this, I was so confused. I had no idea. Yeah.
This has been my third attempt though, coming with what was a so-called basic. And
Yeah.
they've all been like this.
Forget.
Yeah.
I think it's something. Yeah, it's kind of. The idea isn't complicated, but there's so much that goes into it.
Yeah, and understanding even sometimes if you're going through, I remember doing this when I was first learning how to use R, where they would start doing stuff and think, wait, but why would I ever do that?
Yeah,
And what
yeah.
does that mean? And who cares? And how does this apply to anybody? And, you know, it was sort of like taking algebra in high school. Why would you ever do this? Well, now I know why you would do that, you know, and I can see why you would apply it and how you would apply it. But same thing for R. So usually when I'm trying to teach people how to use R, I go, okay, here's what I'm doing, and here's why.
Yeah.
I would ever do that.
Mhm.
You know?
Yeah.
Yeah, I think the problem with Git is the concepts, once they click, they make sense.
Yes.
Because like it was created for developing the Linux kernel, so they had a lot of problems that they need to solve, and it's a very big organization and so on. But like, if you're just starting, it's too many concepts to do something that shouldn't be that complicated.
Yeah, yeah,
It gets sometimes get used in the beginning.
yeah.
So the version control idea is very good. Like you definitely want to learn that and do that. Doing that with Git in the beginning is a bit hard because like the command line interface and all the concepts are complicated.
Yeah.
So.
Although you can do mostly everything with GitHub now.
Yeah.
Online, because you can upload the files for you.
Yeah, so what I was showing to her was actually how we do the Git versioning inside RStudio.
Mm-hmm.
So to avoid all the command line.
Yeah. Whatever it takes. Yeah, whatever works. Cool.
I don't know if I convinced you.
Well, I think I'm still gonna try. Yeah, I'm not. I haven't completely given up.
Yeah, that's
have to
be.
push it off maybe till Friday to try to read up now to it. Because I'm just so lost now that in the next hour I'm not gonna catch back up.
And actually, version control is something that takes some time to click because you never think it's that useful until you start doing that for some time and then something terrible happens and you can roll back and get it.
Yeah, and having like I'm the ultimate in that PhD comic thing. That files, and now I've got this ridiculous name of version 322 -AB/Y.
Yeah,
Gosh, what the heck am I doing?
there's a better way.
And they never teach you that in all of your stats classes. They don't teach you any of the logistical parts of it, of data management.
Mm-hmm.
And that's so important. But yeah.
Yes, that is a passionate topic. We have passion for that topic.
I'm unfortunately discovering it in my 4th year,
Yeah.
that this is something that would have been nice to have known coming in.
Mm-hmm.
Yeah. There's a nice little blog that somebody has on how I manage data analysis projects with RStudio and Git part 1. And she just says exactly what she says. Your file names multiply uncontrollably.
Yep.
Hello, am I unmuted? Okay, I think I am. I am going to assume I am unmuted and go on.
You are in fact unmuted.
Okay. So the next section, I guess I'm going to show you how to use GitHub, but just a question I had. No, you don't have to use Git in a terminal. There are many GUIs that use Git or that wrap themselves around Git. So if you Google Git, the first link, the git-scm link, there will be a button here. For me, it will detect which operating system you're on. For me, it says Linux GUIs for whatever. But it'll just give you a list of a whole bunch of GUIs that for Git. The one I use is called Git Cola. If you download Git through git-scm, it will install one called Git-K or Git-G. That will just come by default. And so, let's see. Hopefully this works. This is what a GUI looks like. Actually, yeah. So this is what a GUI looks like. You know, some have more bells and whistles than others. But for me, my workflow typically, I do most of the communication with GitHub in the terminal. But when I'm doing like the individual commits, I actually will use a GUI just because the GUI will show you a bunch of things at once, like the diff. And it's nice to look at the diff as you're writing the commit so you know what's going on instead of blindly typing things. So I won't show you git k because I don't really use this. So I'll show you what I use. So just for an example, let's edit this bio. And this, I don't know, what else is there about me? I just forget. So here, little tidbit. It's actually pretty cool. Okay, so you can pick any GUI you want. I use Gitcola just because it's really simple and I don't really need much. But you can see that, oh, you guys are not going to be able to see this, but there is essentially the panel on the right just constantly runs git status for you. So for me, I can like hit Control R and it'll refresh, and you know, it'll just give me a list of all modified files. If I click on a file, it'll give me the diff right here. And if I want to write a commit message, I can write the commit message up there. So all Git GUIs have this, at least this basic feature. There is what I like about Git GUIs, or at least this particular one, is let's say you make a change in multiple places on a file, you can actually commit specific lines of a file. So let's say you write a Python function, or let's say you write 3 Python functions, and you want 3 separate commits. Using a GUI, it's really easy to select, hey, you commit stage these particular lines out of the file and write a separate commit message for it. So in my case, I can select these lines and hit S, and it will actually select those lines to be staged and not the entire file. So there's a way to do that in the terminal. I never bothered to learn it. So, you know, there's sometimes, you know, there's better things to learn in Git than just use a GUI to your advantage. For me, I just use it for committing things. So now it's going to say staged. I know, sorry, you probably can't see this. So you get to see what stage. If you want to unstage something, for me, I can double click it. A lot of the GUIs have this feature. It just looks a lot nicer than this. This is just a really simple view. But after you have it staged, you can just write your commit message up here. So the line up here is just like typing git commit -m and in quotes. There's additional space down here. So remember, if you just type git commit without the -m, a text editor will pop up. And so the text editor allows you to type multiple lines. So those multiple lines you can type down here. So you can say 23 and me, and you can say I got sequence, right? And I can just hit a commit button and it's been committed. And that's usually what I do in my day-to-day is I use a GUI just to commit, and then everything else comes back into here. Git status, look at the status. Since this is probably the first time you've seen a multi-line commit, you can see that the one line will only show you the first line, but if I look at git log, it'll give me everything I typed. But yeah, and the main reason why I guess I've learned to just teach Git in a terminal is because GUIs, you can see some of them. There's a lot of buttons everywhere. What is one? Yeah, like source tree. Looks kind of scary. And when I first learned Git, it was actually really confusing for me. But there's like all these buttons, and like I just showed you what some of those words mean. And you know, sometimes out of panic, people will just start random clicking buttons just because they want something to work. You know, and clicking those buttons is the dangerous thing sometimes. And you know, for me, the easiest way is just to make your commit somewhere so you can't screw things up too much, and then you know, be really explicit in the terminal. And other times, depending on how you know your lab or your work is set up, you might not even have a GUI. Like you just SSH into a machine, and all you have is a blinking cursor, and you don't really have any other choice. So learning the terminal does have its benefits, and you can then you know pick and choose which GUI works for you versus like being stuck with the first GUI you've ever played with. Right. Great, cool. So right now, so this morning, or not this morning, this first section, we talked about this left panel. And right now, so this left panel should, you know, minus poor handwriting, should make sense if you kind of squint your eyes. And now we're going to start talking about the right panel. So the right panel, you can think of, I drew this cloud, which is supposed to represent the cloud or the internet. And so now there's a way for us to take what's on our local computer and bring it to the cloud. Or in this case, the correct term is a remote. So remotes, in general, or in very common practice, it's probably something like GitHub, Bitbucket, or GitLab. But a remote is really anywhere that you didn't type git init. So a remote could be another hard drive on your computer, another folder on your computer. It could just be another folder on another machine. Those are all going to be called remotes. It really is just, you know, you type git init somewhere, and wherever you didn't type it is a remote. But again, in common usage, it's probably GitHub or Bitbucket or some other cloud service. By default, just like, you know, this default series of commits has a name called master, by default, the remote that you're connected to is going to have a name called origin. And so instead of saying, you know, the address to where your repository lives on GitHub, you can just say origin. It's really just a shortcut for where the remote is. And the way you talk to the remote is through two other git commands. Git push, which takes code on your local computer and pushes it to the remote. So I want to take everything here and make a copy on GitHub. I will push it. And if I have something on GitHub and I want to update my version, I do a pull. So a pull is, hey, take something from the remote and bring it down to my computer. Right? And that's all these two panels are trying to show, right? And then this cloud has, you know, a master branch or a master chain of commits, and it really will just mimic whatever you have on your computer. The reason why there's like this push-pull system, or why there's a pull system, is because GitHub and a lot of these online cloud services, they're getting more user-friendly, so you can actually, you know, log in to like GitHub and make a quick change directly in GitHub, and you don't have to do it on your computer and then push it up, right? So now that you made a change on the internet somewhere, you need to just update your local computer if you plan to just continue doing work. So that's one of the reasons why there is this push-pull system. And so for the rest of today, I'm just going to show you how you can use GitHub with just your own work, and you're not really doing collaborating. And then next week, I'll extend that and just say, hey, let's say you want to collaborate with 1, 2, or 10 more people. How would you leverage this push-pull remote system? So by now, everyone should have a GitHub account. I made another one for teaching, if you guys saw, but I don't need that. That's for really next week, I think. So let's go to GitHub. And a lot of the words that GitHub uses, Bitbucket will use. The only word that I know of that won't be relevant this week is this notion of a pull request. GitLab uses a merge request, but I'll talk about that next week. So let's say you have something on your computer. Where's my page? On your computer, and you want to think of it as a backup onto GitHub. The first thing you do, you can't actually just say, hey, take this thing and put it up to GitHub. The easiest way I found, and I don't know if there's another way, is when you log into GitHub, hopefully you see some page that looks like this, maybe, or something similar. The thing you're really looking for is this green button that says New Repository. If you have that, you should be good. I don't know what it looks like if you're brand new to GitHub. I think you might be on this page. Do you end up on this page? Yeah, you end up on a page like this. Yeah. So there's two ways you can create a new repository. You can click the repositories tab and click new, or you can click the this is actually GitHub logo, which is an octocat, which is a cat head with an octopus body. Kind of weird. There is a history behind that, but I won't go into it. Maybe next week. It's probably more relevant next week. But either way, click, find that green button and click it. Is what I'm trying to do. And and then everyone should have a page similar to this. This is dying. Uh-oh. Okay. Okay. Stop zooming. All right. So it's going to ask you to create a new repository. The owner, this should be your username. Chances are it is, and you don't have to change anything. And then just give it a repository name. For the most part, you might end up using the same name that you created on your computer, but it doesn't have to be. This is just the version, the title that will exist on GitHub. Just know that if you ever download this version straight from GitHub, this is the automatic folder name that gets created. So for the most part, you want the folder names to be the same so you're not totally confused, but it's not mandatory. Description. It's pretty good to have a description even though it says optional. For yourself, maybe not so much if you, like for me, whenever I do these teaching workshops, it's always date and where or what I'm teaching for. But you know, sometimes you're going to have your own project and you want to give it a description so when other people see it, they'll have a general idea of what this code base is doing. So teaching repo for dib intro, right? And you can change the description. So it's not, you can always change it, so don't worry too much about what you call it. The next thing, public or private. Again, by default, everything on GitHub will be public, and things that are public on GitHub are free. And then if you want something private on GitHub, you have to pay for it. Again, if you're on Bitbucket, total inverse, things by default are private. If you want to pay for it, if you want something public, you have to pay for it. There are student versions of GitHub and Bitbucket, so you can get like at least a few private ones on GitHub if you want, etc., etc. The next thing is we're going to create our own README, but if you just start off a blank project and you know it's going to be syncing with Bitbucket or GitHub, chances are you should probably just check off the initialized repository with README, because a README, you'll see READMEs, files that have README in the title will automatically get rendered by GitHub. So, you know, they come to the page and they already see a block of text describing what's going on. You know, so they're not just like, oh, this is all I see are a bunch of folders. I have no idea what's going on. But we're going to write our own, so you don't have to check this off. And if you're starting a new project, you can, by default, just, you know, this is a Python project, just start off with a python.gitignore. So this is all for stuff. If you're starting one from GitHub, you can. But we already have one, so we don't need that there. Licenses. Essentially, if you ever put something on GitHub, I would suggest put a license on it. It essentially just tells, it is public, and you know, sooner or later maybe someone's going to stumble across this, and they won't. It'll be nice for everyone if they know, you know, do they just need to attribute that they got some bit of code from you, or is there something else? And that will all be specified in the license. Essentially, if you don't want to think about what goes on and you don't care who uses it, and all you really ask for is maybe a link, a link back to saying this is where I got it from, MIT is probably the license you want. If you want, there's also this button that you can click, and it will go to a page called Choose a License, and a small description of all the different licenses are available. And then when you're done, you can click Create Repository. You can pick a license right now. I just know that I won't have any conflicts, so I did it, but you don't have to. Uh-oh. Actually, I should not have done that. Hold on. Darn it. Okay. Don't. Actually, Jessica, how many of your students just created a thing with a license?
None of us, because we are excellent.
Oh, okay. Did you create one with the license? Okay, it's fine. Let me just undo everything so you guys can see. I'm hoping copy and paste will work. Sometimes it doesn't. Okay. So I'm just going to create this whole thing again, just so everyone's screen looked exactly like mine. And it really doesn't matter. You can still get the same information if you are following along and you don't want to restart everything. Yeah, I'll just leave the description blank, just for time. So if you just create an empty one with nothing in it, you'll see this page, and it's going to say there's a quick setup, so you'll get a link. For the most part, everyone's going to use the HTTPS link. If you have SSH keys, or if you know what that is, you can set that up with GitHub and can use SSH keys. Essentially, if you use SSH keys, you don't have to constantly type your username and password. If you use HTTPS, you do. I have SSH keys set up, and there's no way for me not use SSH, so I'm going to use SSH keys, the SSH link, but everyone else should be on the HTTPS link. And so, and the rest of it, so that's just a link if you know what you're doing, but I'm just going to assume no one knows what they're doing because we've all been there. Create a new repository in the command line. So this line, all it does is it creates a README file with the title, git init. So we showed that this earlier. We initialized a repository. We added a file. In this case, they added the README file they created. They made a commit. And then now these are the two new commands that we haven't shown. Or, so that's if you're starting from scratch. And we're not totally starting from scratch. We actually we have an existing repository, and we want to bring that up to the command line. And you'll see that it'll give us these two links. If you want, you can copy and paste it into your terminal, and that's what I'm going to do, but I will explain it. But these two lines are exactly the same two lines at the bottom. And it says git remote. So again, bring up my image. And off the side. And bring it here. So it's going to say git remote. Again, remote is anything, in this case, GitHub. So any remote command is going to say git remote. We're going to add a remote. By convention, the name of that remote is going to be called origin. And then this is essentially the link on GitHub that points to this thing that we just created. And you get that link by clicking HTTPS or SSH. Right? So you'll see that it will change. So this is just a link on GitHub. And so it's saying that, hey, we have a remote. We're going to, instead of typing this massive long link, we're just going to call it origin. And every time we refer to origin, this is what it is. And then we're going to say git push. You don't need the -u. I'll explain what it does, but you're going to do a push. And push takes two parameters, you can say. The first thing is, where do you want to push to? And the second thing is, what do you want to push? So the where is origin, which in this case we defined it as this place on GitHub. And the what we want to push is master, which is the entire chain of commits that we created. So we're going to take everything on our local computer. We're going to make a push. We're going to push to origin. And the what is this whole series of commits. And that's all that git push command is saying. The -u actually just stands for, you can run git push and get a help file. But the -u is, it stands for upstream. And what it does is it sets a default. So in the future, you can just say git push, and it'll by default push to origin master. I've sort of learned that that's probably not what you want to do if you're sort of learning, because you don't want to accidentally do something you don't mean. And just as teaching things, it's just nicer to be explicit so you kind of get a deeper understanding of all the internal workings. Or you can just put -u anytime you push, push, it really doesn't matter, but that's what this flag really stands for. So you'll see me, I won't actually type -u, I'll just type git push origin master. So everyone's going to click the HTTPS link and copy this line, or if you want, copy this link. So everyone's going to do it on HTTPS. I'm going to do it on SSH. So we're all going to copy this link or copy this line. We're going to go back to our terminal. Just to show you, there's nothing weird going on. And we're going to say git remote. We're going to add a remote. That remote we're going to call origin. Again, this is just a name by convention, so if you start Googling for help, that's probably what you're going to see is the word origin and master everywhere. Again, if you want, you could call it pizza. It really is just whatever you want. And next week we'll show you will create multiple remotes with different names. So origin, and I'm just going to paste that in there. If you're on Windows, paste the shift insert. Unless you're on Windows 10 where Control-V finally works. If you're on Linux, it's Control-Shift-V, and if you're on a Mac, Apple V will just work. So git remote add origin. If we run that command, nothing should pop up, and that's good. If we want to look at all of our remotes, there's a flag called -v. -v for list. I don't really know what it stands for. Probably verbose, but. So -v will list all of the remotes that we have. And you'll see that origin will show up twice, and then there's a fetch pull version. For the most part, you don't need to worry about it other than you want to see origin twice, and these two links should be the same. For those of you who are just watching, essentially you can get code from one place and send code to another. That's why there's a fetch pull link, but I have almost never had to do that. And I've always just been very explicit, and this way you don't have this way all your repositories behave exactly the same, and you're not worried about what's going on. So that's how you know that your remote's been correctly added. If for whatever reason you put in the wrong link, or you just type origin and your cat jumped on your computer and hit enter, you can type git remote rm for remove, and then origin. Oops. Or no such thing. And then if you look at that again, that remote was deleted. So you can, this is what I use just because I don't remember the rename command, but if I need to rename or redo a remote, I just delete it and create it again. It's not too much more work. So since I know that added correctly, I'm just going to hit the up arrow and just run that same command again. And just to show you it got added, git remote -v. So back to GitHub. The next line that they show you here is git push origin master. And so what we did was, show you in the graph. All we did was we told our computer when we say origin what it points to, and now we actually want to do the final, hey, take our code or take our prose or our thesis, take everything that we've done and just upload it to the cloud, and that's what the git push command is. So we're going to say git push. It takes two parameters, the where, so origin. So this is again this origin. If you want, you can copy and paste this link. It will do the same thing, but chances are origin is what you're going to type pretty much 99% of the time. And master. Again, master is the linear sequence of commits that we've been doing so far. And for now, in our particular case, if you run git log, that everything that showed up in git log and all of the changes, that's what master contains. If you hit enter, again, I don't have the HTTPS link, so it will just go and do its thing. But for everyone else who use the HTTPS link, no, I use the SSH link. For everyone else who is doing the HTTPS link, it will ask you for a username. You'll hit enter. It'll ask you for a password. Don't be alarmed when you are typing a password, nothing showing up on your screen. just pretend that you're typing your password and hit enter. It's really a Linux or a Unix security measure where people can't guess your password by seeing how many characters it is. So type away, hit enter, and you'll end up seeing a message like this. So Jessica, let me know when everyone's done this. And you'll know everything worked when you go back to your GitHub page, and if you hit refresh, and depending on how slow your computer is going, everything that you've done on your local computer will now show up on GitHub. Right?
Okay.
And so, you know, the simplest backup you can probably do for free for any project that you work on, and I think as long as it's under 2 gigabytes, you can do it this way. Just dump it to GitHub, and you've successfully backed up all your work. So let me know when everyone, at least from UC Davis, let me know when everyone's like up to here.
Yeah, I think we're up to there. There's another question in the bottom of the Etherpad.
Okay. Yes, so all your history is going to be moved to the remote. I'll show you that in a little bit. And yeah, so if you type git log on your local computer, git log, so you can see this is everything that we've worked on. If you go to GitHub and you click on the commits button, that is your git log. So sometimes it's actually easier to look at the log on GitHub, at least for me, than it is to look at logs or differences on your local computer. So now that it's on GitHub, you know, everyone will be able to see this. So, you know, one common thing you're going to probably Google eventually is help I've committed a password, and it will tell you how to uncommit a password. But yeah, you can use this as your online diff tool as well. So bio about myself. If we want, we can click this button, and it'll give us the diff that happened at that commit. So the bio about myself. All I did was, if you remember, I created a file called bio and added the first sentence. Right. So you can use GitHub to explore your history as well.
Can I delete this?
Delete? What do you mean by delete? Oh, like
remove this file that I created since I added the license. Is there a way to like get rid of that, or is it all just
hold on, sorry. Wait, what do you mean? Like delete what? Oh, like the license and readme.
Yeah.
You want to start over from scratch, or?
Yeah, or like just when I come to my dashboard, if I already have, like, can I get rid of the repository?
Oh yeah. So if you're sort of tinkering around, especially you know, it's public and you sort of want to keep everything tidy. Yeah. I quickly did how to delete a repository, but there is a way to delete a repository. So you go into the repository that you want, you'll click on settings, and under settings there's this whole tab called danger zone. And there is one button called delete this repository. And just like the rm command, deleting is permanent. But it's permanent on GitHub. So the nice thing about Git is, as long as somebody has a copy somewhere, they can repopulate everything, right? So it's sort of weird and cool like that. But you can't just straight up delete it. You have to actually type in the thing it tells you to type. They really shouldn't make it copy and pasteable, but it works. But yeah, that's how you would delete a repository.
Okay, thank you.
All right, cool. So let's practice. So we just made a push up to GitHub. So let's make another change on our local computer and see how that can go back up to GitHub. So I talked about README files are really important. So let's create a README file. I use something called Markdown. Markdown, for those of you who don't know, is just really shorthand HTML. It's not as flexible as HTML, but it gets the job done. And if you're in school, taking notes in Markdown is probably like the way to go. So the way Markdown works is there's a header, 1 hash for a header 1, 2 hashes for a header 2, 3 hashes for header 3, It goes all the way up to 6. So 4, 5, 6. I don't think 7 works. So you can have sections. That's essentially what a header is. Markdown also gives you bullets. Bullet 1, bullet 2. You can nest bullets with 4 spaces or a tab. So nested 1, nested 2. I like using 4 spaces and not a tab because different text editors will represent a tab differently. And you can also do ordered lists. So item 1, item 2. What's cool about Markdown is the number that you type here really doesn't matter because it will get rendered however. So it's really nice when you're taking notes and you try to keep a nice ordered list, but you're going to have to insert something in the middle and you don't have to restart a numbering sequence. So Markdown can handle that for you as well. And you can have code which is, let's say, 3 backticks, and you can say in Python print hello, and you can say this is Python code. Right? So you can do cool things in Markdown. But hold on, that's just the beginning of it. Let's just say this is the repo for. So repo is just jargon, slang, shorthand, I don't know, for repository. For dib, hub, or git training. There we go. So let's save this. And again, nothing that I'm doing here should be different or should be new. This is everything that we worked on the first half, which is all I did was create a README file. Again, this README file is a little special, but all I did was create a file. If I run git status, it's going to say, hey, I've never seen this file before. What do you want to do with it? So I'm going to add this file. And now it's going to say, hey, now this file is in the staging area. So I can commit this file. Add README. Now if I say git status, it's going to say on branch master, nothing commit, working directory is clean. That's great. If we go to GitHub, if we try to refresh it, nothing's going to change because we actually haven't done anything to say, hey, update GitHub. So let's make that update. And the way we make that update is git push, and push takes 2 things. Where do we want to push to? In this case, origin, and what, which is master. Yeah. If we hit enter, it's going to ask you for your username and password. Chug away. And then essentially what goes on is it zips up the file and then sends it. So it's sort of like trying to be a little helpful and trying to make things go faster. If we type git status, it's going to say on branch master, nothing to commit, working directory clean, nothing new there. And if we go to GitHub and we hit refresh, and the README file, it has to say the word README. I don't think any MD file will automatically render. It doesn't have to be all caps either. It's just having it in all caps, just, the eye will see it better. But a README file will automatically get rendered. So you can see header 1, header 2, header 3. I guess it doesn't really go past 3 for GitHub. But then you can have bullets, nested bullets, and you can see that the numbering automatically fixes itself. It doesn't really matter. And you can have code using 3 backticks. So those backticks are usually the key to the left of the number 1 on your laptop. So that backtick. So that's like an intro to Markdown for those of you. And you'll see that if you explore a bunch of other repositories, there's going to be this MD file like almost everywhere. All right, cool. So since we're kind of pressed on time, there won't be any exercise other than you can probably do this at home. But GitHub is cool because it doesn't, if you don't like doing your work on your computer, you can open a file and there will be a pencil. So there's a few things. If you want the raw version of this file, you can click raw and it'll just dump you that file in whatever format it is. So this is what that file looked like. If if you're on GitHub and all of a sudden you see a CSV and you want to download this CSV, if you right-click raw, this link is a link that you would get to download that CSV, for example. So that's where that raw button comes in kind of handy. Because a lot of people ask me like, hey, I'm on GitHub, I have no idea how to, I just want this data set, how do I get this? You can right-click raw to download it. Another thing about GitHub, if you just want to, you know, download the repository and you don't care about whatever Git features there are, you can download a zip version of this repository and it'll just come down as a zip for you. But okay, so let's look at this README file, and let's say you left your laptop at home and you made a push to GitHub, and now you're somewhere in the library and you realize that, and you're just like, you know, glancing at all your fine work, but you find a mistake. And how do you edit a file? You can actually use GitHub to edit. So if you're working with like a PI who doesn't want to learn Git or can't learn Git, or just, you know, the PI wants to make a change but you haven't given him or her access, you can tell them, hey, you can just like edit, or they don't, actually, sorry, if they don't have Git installed on their computer or for whatever reason, you can click the pencil and actually Git will open this file for you in the browser that you can make your own changes. So treat this just as if you were on your terminal computer. So this is a Git repo for the data of intensive biology training, and say, right, you can actually make edits for in GitHub. Again, because this is still in the Git system, so think of Git is the program or piece of software that's doing the version controlling. GitHub is just an interface to store all that version control information, right? So we can use GitHub to edit a file, and because it's still Git, we still have to make a commit. And so again, just like that GUI I showed you, the first line will be the -m message, and then the rest is any additional. So make update to README. So you have to write a message. That's sort of one of the blessings and curses of Git. And then commit changes, and now you'll see that this README file got updated. And if we look at our graph here, this is one of the use cases why you need to run a pull command, because now the version on our computer is not in sync with the version on Git. So what we will do is, so if we look at what's in this README, you can see that that line that says, "Hey mom, I'm editing within GitHub," isn't there. And so we can run git pull. Git pull looks exactly like git push, so it takes a where you want to pull from and the what you want to pull from. And it's going to ask you for your username and password. And when it's done, it's going to say, hey, I've made a update, and so these are the 2 commit hashes that's been updated. The version on your computer was here, now it's here. It's going to do something called a fast forward. Essentially, you know, within GitHub, you made a commit to master, and so it's just adding these things to master for you. That's just, don't worry too much what fast forward stands for. It might make a little more sense next week, but for now, don't worry. And then it's going to say, you only changed one file, it's the README file, and you made 2 insertions, or you added 2 lines. So for me, I had 1 line of text and 1 new line, so that's why it says 2. And it gives you like a nice histogram of like how many lines you've added. So, you know, when you're working on a large software project, it's really nice, like when you run a git pull and like there's a nice like histogram of like, oh look, there's this thing that represents 500 lines, and you feel really productive. Yeah, so now if you look at our README, what we did on GitHub now is totally updated on our local computer. So let me see. Wonder if I can do this in 10 minutes. I don't know. but yeah, so you can repeat this process over and over. You can, you know, actually I won't be able to do, I'll do something else within the last 2 minutes. So what you can do is, you can say, look, I'm now editing on my local computer. But here's the trick that I'm going to have everyone try to follow along. Edit the line under the look mom line and save that on your local computer. And then in GitHub, use the pencil and scroll all the way to the bottom and add a line to the very bottom. So essentially, you're making a change in 2 places completely different from one another. So let's say this is a change in GitHub that is not the same as, that is not at the same place on my local. Right, and then I have to make a commit, so GitHub non-conflicting change. Really hoping I spelled that right. So if we look at our local computer, we can run through this whole git add, git commit process. So local computer non, right? So we made a commit. No one yelled at us. We've just, you know, edited our file the way we wanted to for whatever reason. We know we could have been working on something on our computer and then just ran through the library and then saw another mistake and fixed it there, and now we're back home. And now we see that nothing's like matched up. Or we come back home and we're like, oh, we're on branch master, nothing's ready to commit. Let's just push this up to GitHub. So git push origin master. And now it's going to yell at us because the version on our computer is different from the version on GitHub. And now there needs to be a way to resolve it. And so that's essentially what this text is trying to tell you. And you'll see a whole bunch of hints. So it's going to say this is rejected. So, you know, I made this example, so I'm expecting it to be rejected. But chances are, when you see this, you're not going to expect something to be rejected. And it's going to say, we tried to push something to GitHub, but it was rejected because the remote, which is, in this case, GitHub, contains work that you do not have locally. That makes sense because I just made this example just for that. This is usually caused by another repository pushing. You can just think of it as something got pushed to GitHub somewhere else. That's what that's trying to say. You may want to first integrate the remote changes using a git pull before pushing again. So it's saying, hey, do a git pull before doing a push again. So let's do that. Git pull. Again, git pull takes 2 commands: origin, master. And then it's going to, oh, I guess this will open up a text editor one more time. I'm sorry for those who didn't set up Vim. But don't worry about the message. All it's saying is it's merging the changes on GitHub into your local computer. Again, everything in Git has to be tracked, and so this is something that needs to be tracked. If you're on VI, just hit the escape key, :WQ, enter will save and exit. For everyone else, that's in nano, Control-O, Control-X. Then you'll see this message. Essentially what the magical word is: auto-merging, README, and merge made by recursive strategy. Essentially, because this was a change that happened in 2 totally different places in the file, Git is smart enough to say, hey, I can make this decision myself, and I'll just incorporate these changes automatically. And that's what it did. And so if you look at README now, you can see the file. This is a change within GitHub that's not the same as local. And we now have the version on local. If you look at status, everything's clean. And now that everything is clean, we can do the final push to GitHub. And if we look at the version on GitHub before refreshing, so this, remember, we only had this one line on the bottom. And now if we do a refresh, everything's in sync. Yes. So we have a change on my local computer and a change on GitHub. So it is 3 o'clock here. Obviously, the next question is, hey, what happens if I edit a file at the same time? I'll save that for next week, since it does easily go into collaborating, because when you start collaborating, people are going to start rewriting, writing at the same line everywhere. So we'll save that for next week. But essentially, yeah, this is everything you need, the basics of Git, how to interface with GitHub, and you can just right now, like starting today, tomorrow, use GitHub as a remote backup service. The only thing that you might want to, another reason why I do everything in Markdown is you can, if you want, you can also Git track Word documents. Your mileage may vary in terms of using Git diff on Word documents, because those are actually like proprietary or binary formats, so a diff won't actually look very nice. So that's why a lot of people who end up working with Git just write everything in some plain text file, whether it be Markdown if they need some kind of formatting, or just do everything in LaTeX or something, I don't know. So that's why, just because diffs are easier to see. And also, I showed you this .git folder. We can go into it and explore it. But essentially, it's going to have a whole bunch of stuff. So this is everything that's, all the Git information is stored somewhere in here. I have no idea where it is. But essentially, if Git can't make, hold on. So we saw that how Git sort of tracks all of our changes. Under the hood, every commit that we make, it's not really making a copy of that file. All it's doing is it's calculating the difference from one commit to another, and that's what's getting saved. Only the differences are getting saved. So it's actually very space efficient that way. It becomes a problem when you start working with things that can't be diffed, because then that's when a copy gets created. Git knows that there's a change from this file to this other. It can't calculate a difference. So the only difference it can calculate is, let's just copy this folder. So for the most part, when you start working with Git projects, it's not going to be a storage issue for you, unless, of course, if you have like a 20 gig CSV. One, you shouldn't have a 20 gig CSV. GitHub probably won't let you push a 20 gig CSV. But yeah, so for the most part, if it can make a diff, it'll be very space efficient. If it can't, that's when you might have a problem with space. Yeah, that's it for Git and the intro to GitHub. Stay tuned till next week for, I guess, more collaborating stuff. But everyone should, by tomorrow or today or in 5 minutes, back up all their work on GitHub or on Bitbucket. All the words, the layout will be different on Bitbucket, but you should know enough of the words to sort of do mouse hover overs to figure out your way around Bitbucket. Are there any other questions?
I think we're good. I didn't see any that you could add.
Yes, merge conflicts is the reason for next week. I need to save something so people show up.
Okay, excellent. Well, thank you so much. I will stop the broadcast then, and we will see you next week.
Yep, okay. See everyone next week.